Alright, ladies and gents, today we are solving equations. There's still multi-step equations, but now there's 3 choices for our solutions. We'll either have some no real solutions, infinite solutions, and 1 solution. So jumping right into it, we're going to do 3 examples, and then we're going to talk about what those mean and find a pattern. So the first one we're going to write in our notebooks is 3 times the quantity x plus 4 is equal to 3x plus 11. When we're solving this, we're going to follow our same steps just like we did before. Do our line down our equal sign. Remember, when we're distributing, that's just multiplying. 3 times x is 3x. 3 times 4 is a positive 12. Oops, not a 4, Miss Bordix. Starting off rough. 3x plus, that's a 12, is equal to 3x plus 11. Now we need to combine our like terms. My like terms are x on both sides. Since it's a positive 3x, I'm going to subtract 3x from both sides. 3x minus 3x is 0. 3x minus 3x is also 0. So now I have 12 is equal to 11. Since 12 is not equal to 11, our answer, we're going to have to write in words, is no real solution. No real solution. Okay, so what's different in this problem is our variable canceled out. I had the same exact number of variables, and when that happens and I get 2 different numbers, the answer that I'm going to write is no real solution. So let's look at another one, because that was a little confusing. 5 plus x minus 5x equals negative 4x plus 6. Alright, we're going to follow our same steps. Draw our line down our equal sign, and we want to combine our like terms. Positive x minus 5x is a negative 4x. So I have 5 minus 4x. Didn't do anything over here, so I'm just going to bring that down. Negative 4x plus 6. I'm going to get all of my x's back to the same side of the equation, so I'm going to add 4x to both sides. Negative 4x plus 4x cancels out. Does the same thing over here, and I'm left with 2 whole numbers. 5 is not equal to 6, so because of that, same thing, I'm going to write no real solution. So again, my variable canceled out. Once my variable canceled out, my 2 numbers remaining were not equal to each other, so that's a no real solution. I'm going to do one more of those just to make sure that it makes sense. We have a negative 4. Oh, here's an announcement. Sorry, guys.
Can I have Maggie Lane and Lily Lane to the office for early dismissal, please?
Shout out. Negative 4 times parentheses x minus 2 is equal to 2 times negative 2x plus 7. As always, when I have parentheses, the first thing I want to do is distribute. So negative 4 times x is a negative 4x. Negative 4 times negative 2 is a positive 8. Same thing, distribute over here. Negative 2 times 2x. Sorry, 2 times negative 2x is a negative 4x. 2 times 7 is 14. As always, now I want to combine my x's. The opposite of subtracting 4x is adding 4x. I'm going to do it on one side of the equal sign. I got to do it on the other side. Negative 4x plus 4x cancels out. And I'm left with 8 is equal to 14. Well, 8 is not equal to 14. That doesn't make sense. So I put a line through my equal sign. And I write my answer as no real solution. So my answer to all of these is no real solution. Okay? So a little reminder for these, when the variable cancels out, meaning you had the exact same number of x's on both sides of your equal sign. When the variable cancels out and the remaining equation is false or is not true, the answer is no real solution. No real solution. Okay? So that's 3 examples just like that. From here, we're going to go on to our next one, so I'm going to put a little line to keep them separated. And then we're going to start our next round. Oops, let me make it straight. Now we have an equation that looks like this. 2 parentheses x plus 7 is equal to x plus 14 plus x. As always, I'm going to put a line down the equal sign and do my distribution first. 2 times x is 2x. 2 times 7 is 14. So I have 2x plus 14. Over here, I'm going to combine those like terms. I have an x and an x. X plus x is 2x. Now I have to combine my x's. To do that, I'm going to subtract 2x from either side. 2x minus 2x. Oh, that variable cancels out. 2x minus 2x. Oh, that variable cancels out. But now I have a statement, 14 equals 14. Well, that's a true statement. So when you have something where your variables cancel out and it's a true statement remaining, meaning the two numbers are the exact same, then your answer is infinite solutions. You could plug in any number for x and it will always work. It'll always be a true statement. Okay, let's try another one. Negative 32 minus 8x is equal to negative 4 parentheses 2x plus 8. Awesome. Now we have to do the same thing. I'm going to start by distributing. Negative 4 times 2x is a negative 8x. Negative 4 times 8 is a negative 32. Didn't do anything over here, so I'm just bringing that down. Right, well, typical equations, I got to get my x's together. So I'm going to add 8x. Since it's a negative, I have to use those inverse operations. Negative 8x plus 8x cancels out. I'm left with a negative 32. Negative 8x plus 8x cancels out. I'm left with a negative 32. Well, the same thing happened. Negative 32 is equal to negative 32. So once again, that's an infinite solutions. I could plug in anything I want for that x, and it'll still make a true statement. It'll still work out. All right, well, let's do one more just to see if we've got it. 7x plus 5 minus 2 minus 7x equals 3. Okay, line down my equal sign. First thing I want to do is combine my numbers, or I'm sorry, my variables. 7x minus 7x. Well, 7x minus 7x, that goes away. That goes to 0. 5 minus 2, well, that's 3. There's nothing else over here, so I can combine all my like terms. I didn't do anything over here. Well, my variable canceled out again, and I'm left with a true statement. So that one's got to be infinite solutions. Okay. Very similar to our no solutions. It makes sense. It's a true statement. 3 is equal to 3. So we're going to write a statement about this. So we can always remember this. When the variable cancels out, when the variable cancels out and the remaining equation is true, the answer is infinite solutions. Can be any number at all, and it'll work. Infinite solutions. All right. Once again, I'm going to put a line under this so I can keep them separated. I'm going to do one more section, so I have to flip the page. All right, we're all back in. What if we have an equation that looks like this? 2 parentheses x plus 7 equals 15 plus x. To solve this, don't forget, we're going to put a line down our equal sign. Distribute. Distribute just means to multiply. 2 times x is 2x. 2 times 7 is 14. And that's equal to 15 plus x. Want to get my x's together, so I'm going to subtract 1x from both sides. X minus x, that cancels out. I can drop my 15 down. 2x minus 1x is just an x plus 14. Notice that my x did not cancel out. There's still a variable, so I need to continue solving. I'm going to subtract 14 from both sides of my equal sign. 14 minus 14 cancels out. 15 minus 14 is 1. Since x is all alone, x is equal to 1. So that has one solution, and in this case, x is equal to 1. So I would write that as one solution, x equals 1. I like to put a colon in between it to separate it out. Okay, those are just like our old equations, just like we're used to seeing. I'm going to do one more of those, just a little bit more challenging. I'm going to put that down below. It's going to be negative 11x plus 11 parentheses 6x plus 4 is equal to 44 plus 10x. Looks like a lot, but we are awesome at solving equations. So we can do this. Again, we got a number next to my parentheses with nothing in between it. So I'm going to distribute. Bring down that negative 11x. 11 times 6x is 66x. 11 times 4 is 44 is equal to 44 plus 10x. Now I need to combine my like terms. Negative 11x plus 66 is 55x. Be careful, Miss Portix. Plus 44 is equal to 44 plus 10x. Now I want to combine my x's. I want to bring them all to one side. So I'm going to subtract 10x. Cancels out here. 55 minus 10x, I still have 45x's left. Plus 44 is equal to 44. Now I need to get all of my numbers to one side. So I'm going to subtract 44 from both sides. 44 minus 44 cancels out. Don't worry, we still have an answer. Oh, that's equal to 0. Come on, Miss Portix. Since I still have an x, I need to continue to solve. Since I still have that variable, I'm going to divide both sides by 45. And x is going to equal 0. Be careful with these because it still has one solution. And that one solution is x. So just a reminder, when you can solve equations just like normal, just like we've been doing since the beginning of this unit, that's when there's going to be just one solution. In the example above, that one solution was x is equal to 0. All right, make sure you do your Google Form.